morning, everyone, and welcome to Appeon Elevate 2019. My name is Don Clayton. I'm with Intertech Consulting, and I'm here to speak with you this morning about migrating three-tier applications with the .NET DataStore in C# using Snap Develop. For those of you who don't know me, I've been using PowerBuilder a long time. I was a Beta 1 user along with Chris Pollock, and I have been either coding, designing, building, managing, teaching PowerBuilder for nearly 30 years. So it's my pleasure to be here this morning at Appeon Elevate. My company, Intertech Consulting, is the oldest and largest consulting company in North America that specializes in the PowerBuilder product and all the related technologies that come with it. In fact, we were the first consulting company in North America to be independently certified by Appeon and Sybase back in the day to sell and support what is now called the Power Server product. But we started out as a PowerSoft partner in the 1990s, and then we were a Sybase partner wire to wire when Sybase owned the PowerBuilder product and later became an SAP partner. But now we're happy to be Appeon's professional services authorized partner for North America. I'm here to speak with you today about one of our client projects. PEMEX is the Mexican National Oil Company. They have a procurement department which is responsible for purchasing everything north of the Rio Grande. PEMEX has large three-tier systems built in PowerBuilder, two of them, and PowerBuilder is the user interface, and users just love the PowerBuilder UI. But in the middle tier, because this is a three-tier system, the middle tier was written in C and is very dated. The way this works is there are remote procedure calls in PowerBuilder that call into the C code, which is housed in a Nextera application server. The middle tier C code has embedded Oracle PL SQL. And the hardware is aging, as well are the people who maintain this system. And so our solution was to replace the C code and the RPCs with web service calls to .NET web services built around the data store objects developed in C# and deployed using Snap Develop. I'd like to show you a little bit about the LIS application in PowerBuilder. This is a typical PowerBuilder application in that it's multiple document interface. We have used the themes available in PowerBuilder 2019 to modernize the app somewhat. I'd like to talk about why we use the .NET DataStore. Most of the RPC calls were used to populate external data windows manually. Note that there is no SQL in an external data window. So there was a lot of code in both the PowerBuilder client and on the server side that simply packed and unpacked SQL results. The vast majority of this code was removed and replaced with a model view controller pattern where we use the .NET DataStore to retrieve data from the web service and then shared it with the external data windows using Share Data. Replacing all this C code and all of the PowerBuilder code that was used to return the RPCs resulted in a high productivity modernization effort with much less code. And with the basic retrieve and updates handled with the .NET DataStore, the remaining business logic was much more easily refactored. So Intertech created a web API solution using the .NET DataStore. Using these C# web APIs allowed us to open up a whole new world when compared to the legacy C code. For example, we were able to add many architectural items into the PowerBuilder code as needed to help with the API itself, like the REST client, that's a new object for PowerBuilder 2019, but also the HTTP client, JSON parsers and packagers and packers, data stores, and other objects like that. Because we are now in the .NET environment, we were also able to take advantage of a large number of freely available open source .NET libraries like the crypto helper for cryptology, the mail kit to help with mail enablement, Swagger for web service testing, and XUnit for writing unit tests directly within our code. We also created what we called the developer cookbook. This was basically a recipe that we used in PowerBuilder and in Snap Develop to effectually move a window from the C code into the Snap Develop area. And so the way we did this is we would review the PowerBuilder code and we'd find the Nextera RPC calls. Once we had found the RPC calls, we'd go digging through the C code and we'd locate the select statements in the Nextera code. Then we'd determine the data windows in the PowerBuilder UI that needed data stores, and we would write data windows using the select statements harvested out of the C code, and we would fix those data windows up as needed. We'd then test the data windows by passing arguments and reviewing the result sets. Then we would deploy the data windows using PowerBuilder C# model generator into the Snap Develop IDE. Once inside Snap Develop, we created a C# service that would have an interface that would define the methods that the objects would respond to, and then we created controllers with the necessary methods and business logic to achieve our objectives. We were able to test this directly in Snap Develop using IIS Express. We also tested the web services interface using Swagger. We could have used SOAP UI for that as well. And then we published directly from the Snap IDE to IIS. So I'd like to demonstrate the C# data store interfaces for you now. When you bring in a data store into the Snap Develop environment, the data store becomes part of the solution. And underneath the solution, we have the project for the web service itself. Under the services folder, we have our implementation of our interfaces. And here, for example, is a iControlPoint service interface. And as you can see, what it basically has are the create, add, update, and delete methods in order to update data. We also created data store controllers. A data store controller is where the real business logic lives. The controller is where the real work gets done. Here's our control point controller, and as you can see, it has the business logic that gets the real work done. We also were able to develop an automated suite of tests using the XUnit framework. I want to demonstrate that to you now. The testing project becomes part of the overall solution. Here you see that under our testing project within our solution, we actually have a dependency, and that dependency is the project itself. So once you have the project self-linked as a dependency to the testing framework, you can then write tests that will in turn test your system fully. We also used TortoiseGit, Bitbucket for source code control, and other modern development techniques. We also created a continuous integration and deployment environment using Jenkins for that. And what Jenkins does is basically allows us to create automated builds from source code control. So the way that that works is that we created pipeline projects, and within the pipeline project, we would design the pipeline project to pull the source code out of source code control, run the unit tests, and after running the unit tests, we would be able to take a look at the results and see what the results of the unit tests being run were, If there are any errors, those would be emailed to the people responsible for the build, and if the build succeeded, then it would get deployed to the user acceptance testing environment. I'd like to thank everyone who came today to listen to the keynotes. I'd like to thank Appeon Corporation for giving us the opportunity to present our project here this morning. And I want to welcome everybody to Elevate 2019, and I hope you have a successful time here at the conference. Thank you very much.